Hello friends, today we are on day 2 of 3-4 where we are learning mathy methods for solving a system of equations. We learned how to graph, substitution. Now we're going to use elimination. The steps are listed here, which sometimes they don't make that much sense until you do them, but we're going to be lining up x and y terms and the equal sign. So this is going to be easiest to use if you have standard form. And so standard form is something x plus or minus something y equals and then a number. So if we have that form, this is an easier method. You are trying to create an equal but opposite pair so that they will eliminate. So for example, a positive 2x and a negative 2x. A negative 5y would get eliminated by a positive 5y. But the only tool you have in your toolbox to create a matching pair is to multiply. Sometimes you'll have to do one equation, sometimes both, but you're trying to get the equal but opposite coefficients, meaning the number in front. So for example here, plus 5 minus 5. So what will happen is then you're going to add the two equations, just in columns, add up the x's, the y's. One of them will cancel out or eliminate, leaving you with one variable. So you'll be able to find x or y at that point. And then whatever one you find first, you plug it back into one of the original equations to find the other. So you have done this. You did this in Algebra 1, so we're going to do this again and help kind of refresh your memory, hopefully. Now, you are trying to get an x or a y to cancel, and in this case, you already have an equal but opposite pair, and so you don't have to use multiplying. A plus 2y and a minus 2y will eliminate. These become 8x, and the constants on the other side of the equal sign become 16. So it's pretty quick and painless in this problem to find out that x is 2. So I write that in the x spot of my solution. Because keep in mind, it's the same as graphing. You know, if we were to graph it and find out what's the x, y coordinate where they cross. We're just doing it using math instead of graphing. So now that I have x equals 2, I go back to either of my equations to find the y. I would probably use the top one. I'm putting a 2 where the x was. And the reason I would use the top one, it doesn't have any negatives, so it's probably going to be a little bit easier to plug into. And then I'm just using my Algebra 1 skills to solve for y in that equation. So now I know that y is -1. And you can, throughout this whole chapter, check your own work if you want to by plugging those x, y pair, that coordinate back in. So if I put a 2 here and a -1, that would be 6 plus -2, which does indeed equal 4. If I put in my 2 here for x and a -1 here, I'd end up with 10. And this would turn into plus because a -2 and a -1 would turn into a 2, which would indeed equal 12. So you can always check your answers. This is one quiz where you could probably grade your own work. So this one's problematic because they don't line up. So your job is to find the easiest pair. 3x and 6x are going to be easier to match up because I actually just need to multiply the top, but I need them to be not just equal, but also opposite. So I'm going to multiply the top by -2. So then this will get distributed and become a -6x. These negatives cancel, so that's 14y. And then don't forget about this guy. This guy always gets forgotten. That's going to turn into -20. You're multiplying the entire problem by that -2. My 14 was horrible. Now, this one I'm not changing because the 6 x's will cancel or eliminate as is. So I did the multiplication by just the 1 because that's all I had to do. Now these eliminate. Adding up a 14y plus -8, or you can think of it as subtracting. You really just do exactly what it says on your calculator. So 14 and then -8 in this case. Going to be 6y. And then here I would type in my calculator or use my brain. -20 plus 8 is going to be -12. So when I go to solve this, I get y is -2. So be careful with that because when you go to put it in your coordinates, you found the y first. So put it in the y spot. And then when you go back to the equations, you want to plug it in for y. It doesn't really matter which one you plug it into. And in this particular case, the top one might be easier, but they're not significantly different. So I'm going to have 3x minus 7. I'm just taking this top equation, and I'm going to put in the -2 that I just found for y. Be a little careful here because these are going to turn into positive 14. And then I'm going to take away the 14 and get negative 4 and then divide by 3. So this feels like you're doing it wrong, but we're in Algebra 2, so it's okay to not get a whole number every single time. And so I could plug those in and check them on my calculator. Okay, so here it's tricky because you can't turn 4 into 11 and you can't turn 5 into 9. So you can kind of pick whichever one you want, but you're going to need to multiply both rows by something. So I'm going to do the x's and get them to match. And the first thing that comes to mind is to make them both equal 44. So I'll need to multiply the top by 11, and I'll need to multiply the bottom by 4. So keep in mind that they're already a plus and a minus, so I don't have to deal with changing that. So I'm going to distribute this 11, and even though my numbers get big, they'll still work out, and I have a calculator to help me. And in my bottom row, that'll become negative 44, so there's my pair that's going to eliminate negative 36y, and then negative 80. So there's my eliminating equal but opposite pair. On your calculator, if you did 55 minus 36, you'll get 19. And if you did 99 minus 80, like it says, you're going to end up with 19. So even though the numbers got a little scary for a minute, you end up getting a y value of 1. And it's a y value, so it goes in the y spot. Looking back at my originals, and I don't want to use the ones that have these huge numbers, so I'm going back to the originals, and I'm going to pick the top one. I won't get it wrong in the bottom, but there's so many negatives, I just don't want to have to deal with it. So I'm going to go ahead and plug in what I found for y, and what I found for y was a 1. So I have 4x plus 5 equals 9, taking away the 5 to the other side. I get a 4, and then by division, I get that x equals 1 as well. Then I can go back, put a 1 here, 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 and here, because I got 1 and 1 for both x and y, and triple check that my numbers actually make those statements true. All right, so let's take a look at these last two. So in this particular problem, I don't have a pair, but I also don't need to multiply everything, like both equations, because if I can just get these first two to both be a 12, one positive, one negative, I should be good to go. They're already opposite in sign, so I'm just going to multiply the top row by 3. That will make this negative 12x, positive 3y equals 9. In the bottom, I have a positive 12x. So this one gets a little weird because these cancel per the plan, but these actually cancel and I have nothing left. And then these cancel and I have nothing left there. Let's revisit what happened when we graphed. Either we would graph line 1, graph line 2, they would cross, and we would have one xy solution. And that was the most common by far. Or we would draw line 1, we would graph line 2, they would end up being parallel. And parallel lines don't have any shared points, and therefore there was no solution. Or you would graph line 1 and you would graph line 2, and they'd actually end up being the same line. And so since they have every single point in common, I'm calling that IMS. They have infinitely many solutions because every single point on there works. So that's an infinite number of points. So the reason I'm bringing that up is that we have a weird little situation here, but those math problems, not the graphing way to do it, the math problems still have the same 3 options. This happens to be, this happens to be a statement that's true all the time, 0 equals 0. Great. When you get a true statement that's always true, that's going to indicate that you have infinitely many solutions and that if you had graphed it, they'd be the same line. If I had gotten a number statement that was false, like 0 equals 2, then that would indicate that that's never true, so there's no solution. And if I was graphing them, they'd turn out to be parallel. But in my case, I got a true statement, meaning that these would have been the same line, and I actually have infinitely many solutions. Because even though you're doing it using math instead of graphing, it's still going to have those 3 possible outcomes. Let's do this last one and call that a wrap. Okay, so in the last one, I need stuff to match up. I don't know, maybe I'm going to match up the y's. The y's, I can turn the 2 into a 6, but they're both negative. So I actually would have to multiply by -3 to get that to become a +6 and cancel out. So I'm going to distribute my -3, and I have -3x. These negatives cancel, becoming a +6y, and then don't forget this guy, equals -12. The bottom, the 3 x's are going to cancel, but again, Weirdsville, these are going to eliminate also. So I have nothing left on the left, and I have -4 on the right. Well, that's not true. That is a false statement. That is never true. And because it's never true, it means that this one has no solution. If I had graphed them, it would turn out that they were parallel lines. But I don't need to graph them because I'm not using the graphing method. Okay, so here I would just put that there's no solution. So hopefully that helps you with that elimination method, and you are now an expert. Thanks, guys. Bye.